Okay, so welcome and good afternoon to everyone. Yes, my name is Sisson. I'm at Redeemer Lutheran College. I've been there for a number of years now, and I was very interested in taking on board this consultancy role. I guess it was a bit selfish, the reason I originally decided to jump on board. I thought the best way for me to learn about these new senior courses was to get my hands dirty. And it was a great idea to actually get involved with Cambridge. I've learned lots of things and lots about the new syllabuses along the way. And so that was my original reason for getting on board with all of this. So I'm going to share with you this afternoon some of the things that I've learned along the way about how those syllabus documents work and in particular, how well Cambridge meets those syllabus requirements. Because I think as school teachers, classroom teachers, we need to know whether this resource which is being produced by Cambridge is an effective resource. And hopefully I can demonstrate that to you this afternoon. So let's move on. Kim's already mentioned the 4 strands of mathematics. She's also mentioned I've had some involvement in the latter 3, and that's all I'm going to speak on this afternoon, the general, the methods, and also the specialist. Some of you might be electing to introduce all 4 strands of mathematics at your school next year. Some might be interested in only implementing 1 or 2. I think either way, it's going to be a big job ahead for all of us. So if we've got some resources or materials out there which can assist us in doing our job, that will be a great advantage. It will be a great benefit. Now, in putting this presentation together, I was thinking, what sort of requirements would be useful in putting some materials together so that they could be useful for introducing these new senior courses? And I've come up with 2 overarching principles. First of all, whatever materials are presented, you need to make sure they accurately reflect the actual syllabus documents. And as I go through some examples a little bit later on this afternoon, I hope to show you that the Cambridge materials do in fact accurately reflect those syllabus documents. I will refer to the syllabus documents and then I'll swap over to the Cambridge materials to see the tight relationship between the 2. In addition to that, another overarching principle is those materials need to be developed in light of what people have said who are going to be using those materials. So that is the Queensland teachers, the QCAA. And I can vouch that Cambridge has actually done that well and truly. I can just give you 2 examples. When I first looked at the draft of the Methods 1-2 text, one thing that I saw quite early on is that there was a huge use of function mapping notation. Now, if you're familiar with the Victorian syllabus, they're very strong on function mapping notation down there. Well, guess what? We don't use this stuff up here. So my recommendation to Cambridge right from the get-go was saying, let's get most of that out. And true to their word, they did that. So they were responsive to that request. Another thing that I've seen mentioned from a number of teachers as well is that they want some support in the level of difficulty or the degree of difficulty of questions. That was also taken on board by the writers of the textbook. Okay, so as you'll see in the examples that I show shortly, you will find lots of mentions with respect to degrees of difficulty. Okay, so let's get down to the nitty-gritty now and look at some of the specifics as to what these resources have. Well, another good ingredient for any potential resource, you should start off by having some review of your earlier year's work. And I'm just going to actually show you that now. I'm going to show you illustrations of methods, units 1 and 2, specialist 1 and 2, and also general 1 and 2. So let's just quickly look at that. So let me just have a look at the mathematical methods. Now what you'll notice, this is right at the front of the mathematical methods units 1 and 2 text. And those first 2 chapters are review chapters. And you should be able to see why they've been put in there. You've obviously got your linear equations because the students need to have some sort of mastery of basic equation solving, transposition of equations and what have you. And if you have a look at topic 2 there, coordinate geometry, that will be very handy when the students start to do differential calculus later on in the year. So that's a very useful resource to have for the methods. Let me just have a look at for the specialist now. Specialist has, I think, about 4 chapters. You'll notice there's something on algebra. The second chapter is also on number systems. These are all revision. They're not part of the units 1 and 2. Trigonometry, further algebra, and that is it. So that's fairly comprehensive. So you could use those resources maybe at the end of maybe year 10 as a lead-in to what the students might need to do at the beginning of the next year. If I look at the general mathematics, they do that slightly differently. They've got an appendix section at the end of their textbook, and this is what you're going to be getting as a review there. You're going to be looking at things like order of operations, directed numbers, powers and roots, all those basic skills that you would expect students to have if they do that general course. Okay, so all of those 3 resources have those review chapters. Another important aspect of the text is that there are knowledge checks. Each chapter, each topic has a knowledge check. That is to say, before the student starts each particular topic, they are briefed as to what sort of knowledge they need to bring to that particular topic. If they feel as though they're underdone, they can refer to the interactive textbook where there are pre-prepared exercises, and I think tailor-made exercises for the students' level of ability. I think they do a quick test to see where they're at with the background knowledge. On the basis of that quick test, the interactive textbook, I think, actually comes up with a detailed sort of background set of exercises, which is very, very useful indeed. Now, I was mentioning earlier on about the degree of difficulty. Let me just show you here. Here's a typical exercise from one of the texts. This is the methods 1 and 2. And this is on arithmetic sequences and series. And if you have a look at the right-hand side, the SF, of course, refers to simple familiar. And if I scroll down further, okay, we get to the orange, CF for complex familiar. And further down again, complex unfamiliar. And you'll find that throughout the entire text. There's constant references to those degree of difficulty type questions. Very helpful as you deliver the course. Okay, moving on. An integral part of any good text is where you've got constant review of the work that the students have completed. There are revision chapters, and I think they occur after every 3 chapters of work, just like the 7 to 10 series on essential mathematics. Have a look at those categories of questions: technology free, multiple choice, extended response and modelling problem solving tend to overlap to some extent, but there's also modelling problem solving investigations. All of those sorts of things are the sorts of questions that the students will need to be exposed to as they enter into their senior course of mathematics. Okay, let me show you some examples of that. And by the way, at the bottom there, I've also mentioned that not only is there degree of difficulty mentioned, they've also got degree of difficulty tests with the cognitive verbs included. Now that I think is pretty clever. Let me show you by illustrating those. So let's look at the chapter revision first. There's the technology free section, just like the students are going to be exposed to as they enter 11 and 12. My understanding of the syllabus, I don't think they're supposed to be using or exposed to multiple choice questions in the internal assessment, but I think the external exam does require them to answer multiple choice. So there's examples there as well. The extended response, again, that's sort of sort of crosses over into the problem solving, which is this here as well. You've seen these pretty typical questions. And then there's investigations, which are even higher order again. Sorry, degree of difficulty, what I showed you before. But what I want to show you here as well, it's this degree of difficulty. This is on the interactive textbook. And you'll notice the test is divided into those 3 categories. But have a look at the bold words. Do you recognise those bold words? They're the cognitive verbs. And I guess what we should be doing is encouraging our students to identify those cognitive verbs, because that's typically what they'll get in that external exam. And we should be getting onto those things very early on in the piece. Also, there are full solutions to all of the aspects of the work in the textbook. Here's a typical example, clearly laid out. Kim, I think they're part of the interactive textbook, is that right? Yep. There are examination practice questions in those review chapters and also in the online teaching suite. But Michael Evans, the lead author, is talking about the following. As we produce, or as Queensland produces more external exams, he's happy to put those external exam questions on the interactive textbook site. And that will be very useful indeed. Okay, very useful. But if you want that to be a reality, I think you need to give feedback to Cambridge to tell them this is something which would be well worthwhile. Okay. Right. Now this was an issue. If you go back to when the syllabus was first written, you remember when there was this big hullabaloo about should we be using CAS or non-CAS calculators, and a lot of the examples, or all of the examples in the first version of the textbooks were all CAS based. And then we have the edict from the QCAA to say, well, we don't want CAS based calculators, it's all got to be non-CAS. Well, they've gone through and rewritten all of those graphics calculator examples. So those examples are designed for 4 types of calculators. If you're a TI user, the examples relate to TI-84. They also relate to the TI Nspire CX non-CAS. If you're a Casio calculator school like our school, they're designed around the FXCG20 and the FXCG50 series. So let me just show you how that would look. So this is typically how those examples would appear. So this is the TI version, and if I scroll further down there's the Casio version. So they should look fairly familiar to you if you're using any of those two already. Okay, so just be mindful of the fact that all of those are non-CAS based calculator examples, and be aware of the fact that of course the general mathematics and the essential mathematics students don't use graphics calculators. All they need is a scientific calculator. There are guides in the interactive textbook on the use of the scientific calculator. There's guides on use of spreadsheets and also Desmos widgets, and I'll let VJ talk at great length about that shortly. I was at the Gold Coast presentation yesterday and he did a wonderful demonstration of Desmos. I don't know how many of you here use that facility, but I thought I knew a lot about Desmos because I incorporate that into my lessons, but VJ taught me a lot, and I'm sure he will teach you a lot this afternoon as well. But of course, that last bullet point relates to the essential maths and the general maths course. All right, so now what I'm trying to do, having talked about the overarching ingredients of what are part of this series of textbooks, what's important is now to see, let's look at how the Cambridge texts match up with the syllabus documents. Now, I can't do a complete coverage. All I'm going to do is take snippets of those courses and see how Cambridge addresses those syllabus elements. And the first one I want to illustrate to you is linear equations. And if I have a look here, you've got Well, let's have a look. You've got linear equations. What do we have to do in linear equations? According to the syllabus document, we've got to solve them. We've got to develop linear equations from descriptions in words. We've got to construct straight line graphs, determine slopes and intercepts, construct and analyse straight line graphs with modelling and problem solving. We need to do simultaneous equations, and importantly, have a look at that last step, piecewise linear graphs and step graphs. Now, that is quite unique to the Queensland syllabus, okay? So what the writers had to do, they had to go back and find examples of where that can be used and incorporate that into the text. Can we just see how the textbook actually lends itself to fulfilling those requirements? Let's do that now. If I can come here now. So let me have a look. So first of all, so there's solving equations, and I can scroll down. They get progressively harder, of course. Linear equations from words, that was one of the descriptors or the subject matter in the syllabus document. Again, I can scroll down. You can probably see some of those. Bear with me. Here we go. So obviously quite a few worded questions there. Straight line graphs. So really what you should be able to see here is basically a one-to-one mapping of the subject matter with the actual items listed in the text. Slope and intercept form. I won't labour the point, but as you can see, each of these sections are fulfilling the syllabus requirements. Linear modelling, starting to get a bit harder now. Let me just jump down to the exercise. Let me show you the sorts of things that will be asked here. Okay, lots of worded type problems there. Lots of analysis, lots of synthesis going on. Simultaneous equations. Simultaneous equations with technology, and interestingly enough, because the students don't need a graphing calculator, okay, this is a good a good reason why we might use Desmos in a situation like that. Okay, so if you want to actually analyse graphs, construct graphs, well, Desmos will be a great resource for you to use. And if I just jump to that last section now, there's the piecewise and the stepwise sections of the graph. And that, again, was added because that was a requirement of the Queensland syllabus. Okay? And that's important to realise. Like, it's not just something which is being bolted on from New South Wales or Victoria. As a consultant, I think it was my role to say, well, look, here are the various elements of the subject matter. What's missing? What's missing in that first draft that you are presenting to us? And that was a very good example of how the writers have responded to the demands of the new syllabus documents. All right, let's move on further. So that was linear equations. I'm going to stick with general maths for a little while because I think for most of us, general maths is going to be one of those subjects which is so different to what the current Maths A course is. And I think we need to convey to our students, particularly those students who are in the middle of year 10, you might need to consider maybe going to a general maths course, enrolling in a general maths course rather than a mathematical methods course, because you'll see it's quite complex. And let me show you here with the trigonometry section. Now, many elements to the trigonometry. I'm not going to talk about all of them, but in particular, what I want to focus on is that we now have to look at the sine and the cosine rule. And we also have to look at bearings, not just with respect to right-angled triangles, but bearings with respect to non-right-angled triangles. That is complex stuff. It's complex stuff. So let me have a look at how the textbook responds to that. Have a look at the complexity. So there's the stuff on the sine rule. Notice there's even the derivation. Now, that would even frighten a lot of method students off, wouldn't it? If I then move on to the exercises, typical, isn't this stuff we would have done in Maths B? Okay, this is now what's required in the new general maths course. The cosine rule. Again, look at the derivation. Cosine rule exercises. And what I want you to notice here, I'm not sure whether you can see that clearly, but a lot of those problems there are bearings problems with respect to non-right-angled triangles. Well, if you think about how your Year 11 Maths B students cope with some of those, you'll see that the general maths students will find that very, very hard indeed. Very hard. So for me at my school, when students come to make choices about what subject, Mr. Sisson, do I need to enrol in grade 11, I would be recommending for many of my students who are around the middle of the cohort to be opting for something like that. I really would. And finally here, we've got further problem solving. Again, very involved, very complex type stuff. Now, you can use as much or as little of those materials. What I like about Michael's writing of these materials, they're very comprehensive. There's probably too much there, but from my perspective, I would prefer to have too much rather than too little. I really would. Some really, really good stuff. Matrices is the last general maths topic I want to do. Now, if you've taught Maths C before, this is relatively straightforward, but for a student who's not so strong on their mathematics, they would find that reasonably hard. So I'm just going to scroll down to the second. I just want to focus on the matrices, bear with me. So what is it asking us to do there? Well, first of all, we need to talk about the reasons why a matrix is a good way in which information can be stored. It gives some examples of where matrices can be used in real life. It talks about different kinds of matrices, like row matrices, column matrices, zero matrices, etc. It talks about matrix operations, addition and multiplication. Talks about scalar multiplication somewhere, I think it does. Yes, it does. Talks about powers of matrices, and it talks about an application of matrices in the area of network communications. Well, let's see how the text does that. Here in the introduction, it gives some sort of rationale why matrices should be used in the first place. Talks about some sort of typical practical situation where you could use that. The elements of a matrix, matrix types, remember those definitions in the syllabus document, definition of row matrices, column matrices, square matrices, what have you. I'll just have a look at the exercises. This is typically what they'll do here. Notice the definition of the degrees of difficulty on the right-hand side there. We've also got some application to practical situations. Operations. And this is what I like here. It tends to break the rules for multiplication down, helps the students to understand how we actually multiply matrices together. And then if we have a look at the power of a matrix, which was in the syllabus document as well. There's problem solving there. And finally, communications, network communications, and this is exactly what is being spelled out here. So again, a very comprehensive coverage of the syllabus, all right? I wanted to show you those 3 units simply because those 3 units illustrate the degree of difficulty that this new general maths course has. All right. There are other aspects which are very similar to Maths A, I should say. Things like consumer arithmetic and what have you. But those are going to be very, very challenging for a big number of students. Very demanding indeed. All right, let's have a look at some of the other courses. And I'm now going to have a look at specialist maths. And I chose this one because this is probably brand new. in the units 1 and 2. We're looking at circles. Look, we're supposed to be doing circles in year 10, in the year 10 course. I must say, because of time, we don't get on to do circles at our school, but this is what the students will be required to do if they study specialist mathematics in units 1 and 2. So again, what does the syllabus document say there? Let me just skip by the top section, and I'm going straight to the circle properties and proofs, which is that middle section. So what are the sorts of things we have to do, or get the students to do? First of all, there's an element of proof in there. Proving circle properties, like the angle in a semicircle is a right angle. The angle at the centre subtended by an arc of a circle is twice the angle at the circumference. These are stock standard stuff, or things that we get the kids to use, but we don't necessarily get them to prove the rules, do we? So this is how it might be different between year 10 and year 11. Chords of equal length subtend equal angles at the centre, and conversely chords subtending equal angles at the centre of a circle have the same length, blah, 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 blah. As well as proofs, don't forget at the bottom there, it talks about solving. And let me have a look how the book tackles that. So here's the first, one of the first things that was mentioned there. It talks about the angle at the centre of the circle is twice the angle at the circumference. So that's the statement. And of course below that is the proof that goes with that. Moving on. Opposite angles of a cyclic quadrilateral are supplementary. Well, how do we go about proving that? Well, there's the proof for you. I won't labour that point about proofs, but that just gives you an idea. Let me have a look at some of the exercises. It's not all about proof. Some of it is just finding the unknown angles, knowing those rules. But if you have a look towards the end there are proof questions. Let's have a look. Prove that if a parallelogram can be inscribed in a circle, then it must be a rectangle. Okay, where to from there? There was another proof. The tangent is perpendicular to the radius. The alternate segment theorem, chords in circles, what have you. Again, a very close match between the syllabus document and what is required. Where to from there? We're almost done. And I've left these two last slides because this has been creating a bit of angst amongst Queensland teachers. I've attended a number of QCA workshops, and it seems to me that when teachers have looked at these new Unit 4 topics on probability and statistics, they're very concerned as to how to approach them. One of the Unit 4 topics in math methods is the one on sample proportions. Yeah, we're familiar with things like the binomial probability distribution and the normal probability distribution, but as soon as you start talking about sample proportions and confidence intervals, that becomes very different to what we've been exposed to before. And I think for a number of us, we might feel very uneasy, very apprehensive. And I just want to assure you that because these topics have been taught at length in the Victorian system for a very, very long time, they've done these sections particularly well. Very, very well. Let me show you the syllabus document on sample proportions and then have a look at that. Okay, so what are we supposed to do? Well, according to this, we're supposed to understand this concept of a sample proportion represented by the variable p hat, and we need to understand that it's got a mean, mu, and it's also got a standard deviation, and that standard deviation is dependent on the number of items in the sample. We need to also understand the normality of the distribution of the sample proportion for large sample sizes. We have to do some simulations representing sample proportions. And then it moves on to things like confidence intervals for the sample proportion. It talks about something called the margin of error, and it also talks about something about levels of confidence. Let me just go through the text and show you how the text addresses each of those items. So first of all, a nice gentle introduction to what a sample proportion is. Okay, it talks about population samples, then it talks about this concept. I'll just remove that. Then it talks about what a population proportion is, and notice that for the first time there, it's defining this thing called a sample proportion. It then looks at the distribution of the sample proportion, and it just uses basic probability there to actually establish those probability distributions. Then it talks about how we can actually come up with those distributions for large sample sizes. It then starts to look at how we can find means and standard deviations of these distributions. And then now you start to see how this starts to overlap with the syllabus document. You'll notice it says here that when you've got a random sample, while the expected value of that random sample of the sample proportion is p, and the standard deviation is given by that square root expression on the right hand side, exactly what is described in the syllabus document. It then talks about the normality of that distribution for large sample sizes, straight from the syllabus document. Confidence intervals. Let me just jump down to confidence intervals down here somewhere. There we go. There's a 95% confidence interval for the sample proportion. But beyond that, it talks about margins of error, straight from the syllabus. And finally, it talks about changing levels of confidence. So if you don't want it to be a 95%, you might want it a 99% confidence interval. Okay, what is this value of k? That is really almost a one-to-one matching of the syllabus document with the text. So the reason I've said this is because people are concerned about teaching this stuff because it is way beyond what the students do at the moment. But rest assured, that resource can help classroom teachers implement that section of the coursework. I'm absolutely confident that it can. And just to finish off, there is also another probability and statistics unit in specialist maths, and this is called statistical inference now, similar to what we were doing before, but rather than looking at sample proportions, it now looks at sample means. Quickly canvassing the syllabus document. What does it say here about the sample means? Well, notice the sample mean is represented by x bar. It will have a mean of mu and a standard deviation of sigma. It talks about simulations there. Again, notice as we move down to the lower section, it talks about confidence intervals, further simulations, estimating using x bar and s to estimate u and sigma, etc. And again, if I could just quickly show you how the textbook approaches that. We can then look at how the distribution is affected by sample size. It says here that you can approximate the sample mean by normal distribution having a mean of mu and a standard deviation of sigma over root n. The central limit theorem is very important. What it's really saying there, it doesn't matter what distribution you have for your sample mean, so long as the sample size is large enough, that distribution will approach a normal, whatever distribution you start with. Okay, and I'm not sure if that's explicitly mentioned in the syllabus document, but it's a key part of understanding all this work. Then we go on to confidence intervals, just like for the sample proportions, margins of error, just like sample proportions, and finally changing the levels of confidence. Again, almost a one-to-one matching of what the syllabus requires. So hopefully, if I go back to what I said early on in my presentation, one of the key essentials, I think, for any set of resources which are developed, they should closely match the syllabus documents. And I hope by going through those explicit examples with you, I've demonstrated that those Cambridge series, in fact, do that. Okay? And that's me finished.